Hello, everyone. Thank you for coming to the presentation today. My name is Vecchio, and I'm a software engineer for LexisNexis Risk Solutions. I've only been a software engineer full-time for a couple of months. I started last year as an intern, and then I took a part-time job while I finished up school working on this project. If you have any questions, feel free to ask them in the question section or in the chat. We'll do our best to answer them. The title of the presentation is Parquet Support for ECL. So before we start, I'd like to give you a good understanding of what Parquet is and some of the motivations for working with it, and hopefully you'll have an idea of some advantages that you can gain and think of ideas that it can help you. So Parquet is now integrated with ECL, but for a while it's been integrated with Spark and Hadoop, which are great HPC applications. Their high-performance computing platforms are well-tuned for the Parquet format. AWS and Azure are also increasing their support for Parquet because of its many advantages when working with big data across many machines. Parquet support is spreading, and now it's come to ECL to make connecting your data with other sources and services even easier. Not only does being able to work with Parquet make it easier to connect to other services, but it also makes reading your data faster, and it makes your storage more efficient. So reading and writing large amounts of data is something that HPCC systems is great at, and now its capabilities have expanded with Apache Parquet. You can read and write columnar data with ECL and take advantage of the efficient data retrieval and advanced compression techniques offered by it. Along with Parquet comes implicit data compression, as well as multiple complex compression techniques. These are designed to handle bulk data, as well as complex nested structures and any kind of data type that ECL supports. Parquet is a structured file format, meaning there is a lot of information that's stored alongside your file in the metadata. This metadata improves reading and writing Parquet files because you have a better idea of where the data is stored in your computer. This improves random access, which is what a lot of searching is. It helps. It's a faster comparable to a row-based structure, which I'll be talking about in the next slide. And to explain this better, I'm going to show some formats that are already integrated with ECL. So what are some formats that are currently supported by ECL? There are four main formats: CSV, JSON, XML, and blob format. You may be familiar with these, you may not. They fit into two main categories: structured and lightly structured data. It's not really fair to say they have no structure because all data has some structure to it. So let's start with file format that has very little structure. The CSV and blob formats. Starting off with the blob format, it stands for binary large object, and it is just raw binary data. This will be your image and video storage, or any data that you want to keep in the raw binary format. This has very little structure and is simple to read, but doesn't come with any optimizations that structured data does. Another similar format is the CSV format. This is much more common on the list. It stands for comma separated variables, and it's just that. It's a list of comma separated variables, each containing a field. So while it is easy to read, it can take a while to parse because you have to read through every line, and there's no good organization to it, so you can't read specific fields from it without jumping across, or without reading across the whole line. So this is where structured data formats come in, like JSON and XML. These offer much better, much faster access through things like paths, so you can have access to a specific data member. And this is where Parquet is going to excel with access to specific data members. So how is Parquet different? So we just looked at varying levels of structured data, but all of those file formats were row-based, meaning they write your data to the computer that is written row by row. The difference between Parquet, which is heavily structured data format, is that it's column-based. What this means is that if you look at if you look at the data here, it gets stored row by row. So all the fields get stored one after the other, as opposed to column data, where all the name fields get stored together and all the age fields get stored together. This offers a lot of efficient access, and we can get a lot of performance out of this knowing this. So Apache, how do we do this? Apache Arrow's file reader API allows us to easily select the columns that we want to read. This allows us to omit significant portions of unneeded data. A lot of filters and searches require you to read through portions of data. And if you can omit portions that aren't required, you can save on time and resources. With Apache Arrow, reading your data that's stored in the Parquet format is much faster than reading the same data stored in other formats. Parquet is much more efficient with data storage, meaning that a data set currently stored in CSV will be smaller when you store it in Parquet. This is due to the implicit file compression. So I mentioned Apache Arrow a couple times. What is it? Apache Arrow is the library that offers us access to Parquet. It is essentially the glue that holds Parquet and HPCC systems together. Through it, we get the access to data types, complex nested structures, and fast and efficient I/O. So what are advantages for Parquet and Arrow? They're pretty obvious. It's faster and more efficient to read and store your data. You get access to the entire Apache ecosystem with Spark and Hadoop, and you get to connect with other projects through Azure and AWS. As well as now that it's integrated with ECL, it is much easier to work with. The Parquet plugin is a better solution than there was before, which makes Parquet even better. So what is the Parquet plugin? Now that you have a better idea of what Parquet itself is and some of the motivations for working with it, let's talk about how we can do that with ECL. So before this plugin, there wasn't really a good way to work with data unless it was already in an HPC cluster like Spark or Hadoop. But even then, once it's in the cluster, it's hard to get it out and move it around if you can't get it out of Parquet. But if you don't need to get out of Parquet and you want to work with it in ECL, you don't have to deal with converting Parquet anymore. Now that it's integrated with ECL, you have the full power of the HPCC systems at your disposal. So the Parquet plugin offers a clean interface in ECL for working with Parquet files. With just a few lines of code, you can fully leverage Parquet and Arrow functionality to analyze and transform your data without ever having to convert it from Parquet. If you're already an ECL user, this will look similar to you, but if you haven't, I'll explain the syntax and what's going on. As well as I'm going to do a live demo shortly. So if you have any questions, please feel free to ask them either in the chat or in the question section. We'll do our best to answer all of those as they come in. Not only does the plugin offer a clean interface for reading data, it also supports all of the complex partitioning schemes supported by Arrow, as well as all of the ECL types and nested record structures that are supported by ECL. So the read function takes two arguments: the record structure of the file that you are reading and the location on your computer where you want to read the file from. ECL makes it easy to read large Parquet files with complex structures. Thanks to Parquet's rich data type support through ECL, every data type can be read and is supported in the ECL plugin. HPCC platform supports multiple nodes, and therefore you can read data parallelly on Thor. This is much more efficient than having to worry about it yourself. It's much easier to set up, and you can fully leverage HPCC and Parquet. So on the writing side, it's very similar. The write function also takes two arguments. The record set definition that you would like to write and the location on your computer that you want to write the Parquet file to. The, the plugin can split up the Parquet file depending on how many Thor nodes you have. So if you have 4 Thor nodes, it'll read and write 4 Parquet files at a time. And if you want to read and write on a single file, you can read with Thor nodes. So you can read parallelly a single file, or you can write a single file on each Thor. And all of this is very simple. You can do this with a single line, and I'll show you how to do that very soon. So now that I've introduced the plugin and what it can do, I want to talk about some things that may not be 100% implemented today, but will be coming out soon and most likely before this presentation even airs. So one of the things that I want to start with is the complex compression techniques. These are really important and a huge part of Arrow. And there is implicit file compression, but it's not nothing compared to the actual compression techniques. And once these are implemented, you'll be able to really compress your large files, which will be huge. As well as there are many general performance improvements that I can make. So right now, the plugin is you can already read data faster than through the CSV format. So you already have the full advantage of Parquet. But this was a first attempt and it's still in development, so it'll only keep getting better. Okay, so now we're going to move on to the live demo portion of the presentation, where I'll show you just how easy it is to work with your Parquet data in ECL. I have a couple different data sets that I'm going to be working with. I have a large data set that has about 94 million records, which is full of just random GitHub commits from 2019. That's about 15 gigabytes. So I'll show you how you can easily work with really large data, all stored in Parquet. And then I'll have some smaller data sets, around 1 million records, just to show you some quick things that you can do with ECL and Parquet. Okay, so we're going to jump over to the ECL ID and I'll show you how that gets going. Okay, so if you are familiar with ECL, this will look very familiar. This is the ECL ID. So we're going to start by creating some definitions. So it's important to name your files correctly. So we're going to start off, since we're creating a file definition, I'm going to start off by creating file and then GitHub, and then just because it's GitHub data, and we're going to read the large file. So what are we going to? Okay, so the first thing that we need to do is import Parquet plugin. We do this because the Parquet plugin isn't fully integrated into ECL like some of the other formats. So you still have to import it and you have to install on top of your running cluster. So the next thing we're going to do is export a definition for the file. Okay. We're going to use a module just because it's a nice way of keeping this type of data together. And then this is where it's important. So the only thing you really need to worry about is the record structure. So this is how the data actually looks in Parquet. And I can make this bigger. So you can see there's, I think there's 11 fields. They're made of strings and integers. This is the information that the platform needs to go ahead and read the actual data. And then we can export file And we're using the read function, just like I showed you earlier. And we're going to pass in the layout, which is the record definition, and the location on disk that we want to read from. So once we have that, we can check it, and there's no errors. So we're not going to submit this just because it doesn't actually do anything. It just exports some definitions. But what we're going to do is we're going to create it's called a builder window runnable, and that's going to let us actually execute some code and it's doing what's called an action. So let me create another file. We're going to name this builder window runnable GitHub. And now what we can do is we can just take that definition that we created by importing the money sign, dollar sign is all. So you can import all in the same directory that you're in. So we import that file we just created, and then we can get reference to it. And then we can just go ahead and do some queries. So now that we have access to this data set, we can treat it like a normal ECL data set. And we can say, well, since this is a bunch of commits, let's get all the commits that were made to HPCC systems. So the way we do that is we just use normal ECL syntax, GitHub, with some logic where the repo is equal to HPCC. And that will give us all of the records that were made, all of the commits that were made to the HPCC platform. And then we can output this. And we can check that. Okay, and that's good. And then we can submit that. And then that'll run. And it'll take a couple seconds just because this is a very large data set reading about 94 million records. But it's going to search through the entire data set and find any match for HPCC platform. And then it's only going to return the first 100 records in the output just because that's the default setting for the ECL IDE. You can have it output more records if you want, but it's also going to return a count. So we'll see how many total records, how many total commits were made to HPCC systems. And it should be done here in a second. So I can start, I can make the next file while we wait. So we're going to create a definition for small, and that just finished. So you can see how long that took. We go back here and we go to graphs. Let's see, let's go to. So we can see it took 54 seconds. And we have all of the commits. This is what the data looks like. And there were 21,000 results out of the 94 million records that were made to HPCC systems. And it returned those results in 54 seconds, which is pretty cool. So for some faster results, we can do the same thing with a smaller file. Speed things up. I have it already made. So we still have to import Parquet. Then we can go ahead and define, this is a different data set in a different location, but it has the same record structure. So we can check that and no errors. And then we can create a new builder window runnable file. And some nice queries that we can do. Just to show you how easy it is to, so this is all working with Parquet data. You can see we're doing the same thing, importing a definition to the data set. And then we're creating a table. We're selecting 3 rows out of the dataset and creating a table after that. And then from that, from the definition that we just created, we're going to get all the records for commits that were made to the React repo and all the commits that were made with the language C++. So we can check this real quick and submit it. And since this is a much smaller data set, this will be much quicker. So you can see here's the 3 columns that we selected. Here's all of the, wait, this is the React repo commits and the count. So there was 1,100 of them. This is all of the C++ language commits, and there was 394,000 of them. So it's pretty cool. So you can do that all super easily with your Parquet data. Take full, I mean, if you're familiar with ECL, this is all going to look very familiar to you. But if you're wanting to use this with Parquet, this is really nice. Okay, so now to do something else. So let's say you have some CSV that you want to convert to Parquet, and maybe you want to spray that to the cluster and convert that to Parquet through ECL. So if you're familiar with the steps of spraying to the cluster, it's fairly simple, but I'm not going to go into that right now just because we don't have time. So real quick, let's see. So I've already sprayed the file to the cluster, so we don't have to worry about that. So we just need to create a new record definition. So we're gonna call that file. It's a file, and then since it's a Spotify data now, it's in the CSV format, we're gonna call it Spotify CSV. And just to save on time, I'm just gonna paste it in. And so here's the layout, the record layout of the Spotify data. As you can see, we're now using the dataset function because this is CSV, which is fully integrated into ECL. And it's going to be very similar to our Parquet read file. But this is a CSV file on the platform that we're going to be, that has been sprayed on the platform that we're going to be reading from. So we create the file definition. And then what we want to do is we want to write that to Parquet. So now we can create another builder window runnable. And we're going to call it GitHub or Spotify and CSV. And this is going to look very simple as well. So we're just going to import the file definition we just created, and we are also going to import Parquet. So you have to do that every time you want to use the library, just because it's not fully integrated yet. And then you can just use this one line to write to Parquet. And there is some stuff going on here. I'll explain that. So the write is the write function from the Parquet library. That's just going to take a single data set and write that to a Parquet file. What this distribute is saying is that we want to split up the data evenly among the Thor workers so that the workload gets spread out evenly across your cluster, so you don't have any wasted resources. So we're going to say distribute with a skew of 0.05, so it's evenly distributed. And then we can check that, make sure there's no errors, and we can submit that, and it'll write a Parquet file. And it's not going to have any output because the write file doesn't return anything. But there we go. So it succeeded, the working succeeded. And then we can create another builder window runnable just to, another file definition so that we can read that Parquet file that we just wrote. So if you want to take advantage of Parquet and store your data in Parquet, but still work on it in ECL, you could do that very easily. So you just need to another definition. Parquet, call it Parquet. And similarly, we're just going to import $sign and import Parquet. And we can just borrow the layout from the other definition that we created just because it's the same. And then we use the read function again. And we can check that. And then create a new builder window runnable file. Okay. And then just quickly read the data back in. So you can see all the Spotify data. And there was about 1,100,000 records. And that job completed in about, let's see, how long did that take? 2 seconds. So reading your data through Parquet, fast and efficient, easy, clean interface. And just a quick comparison. So we can create, so now that we have a CSV file and a Parquet file, we can compare the read speeds. So let's create a record definition for a large CSV file. And this is the same 16, 15 gigabyte. I believe the CSV file is 16 gigabytes and the Parquet file is about 15 or 14 gigabytes. So you do get some compression from there just by storing in Parquet, which is nice. So there's the large GitHub file, and then we already have the large Parquet file. So we can just create a new builder window runnable. I'm not sure what's doing. Let me try that again. Okay, so we're just going to create a new builder window runnable and CSV. Okay. This way you can really see the speed comparison, and also show you some cool metrics. Hopefully, if it. So I think I just need to change. Okay, so no errors. So then we can run this job. So this sequential is just going to make sure that they happen one after the other. That way, you don't have them stepping on each other's toes and impacting the performance at all. Because the platform will really try to optimize it, and it'll do a lot behind the scenes. So we'll just, to keep it simple, we put the sequential, so it happens in sequential order. So it's going to read the entire CSV file through the platform, and then it's going to read the entire Parquet file through the platform, and then we'll get counts of those, and they should match up. And we can hopefully look at the metrics, and we can see the times for each of them. So okay, So you can kind of see there, it's hard to see. But you can see the first read, that's just the first 100 rows. This is where it's actually reading through the entire file. So you can see if I refresh it, it'll take a while. So right now it's at 58 million records in 62 seconds. So reading through the CSV file is going to be a little bit slower than reading through the Parquet file, but should be there. So yeah, so it only updates every 30 seconds. So that took 85 seconds to read through the CSV file, and we got 94,361,000 records. And for the Parquet file, we'll refresh here. Okay, and that's at 41 seconds. Okay, so it's almost done. There we go. So you can see it split up the jobs evenly. It did all of them in sequential order. So it did, yep, got the same count, 94,361,402 records. And CSV reading through the platform, 85 seconds, and the Parquet plugin was 53 seconds. So you get a lot of performance out of reading Parquet data as opposed to the other formats. And as your data gets bigger, this gap is only going to get wider. So Parquet really has plenty of advantages, and hopefully now you can see how easy it was to work with. So I think that's all I got for you today. Please, if you have questions, feel free to ask them. If there's anything that I didn't cover in this presentation, feel free to email me. Yeah, thank you, everyone.